Okay, let's look at this question here, which is taken from one of the school tutorial question. I think it's RI. This is on application of integration. This is a very classic example of question which involve integrating like modulus functions. Okay. Now, before you start doing such integrals, I would just encourage students to just plot into the graph first and understand the modulus graph before you even start integrating. It's not as straightforward as it seems. Okay, so just bring out a GC and just plot it in calculator. So how do you plot it in is usually I would suggest students to plot one without the modulus function, then the other one with the modulus function. So cosine x right here. Okay, so then the subsequent one will be, we're just going to call out the modulus. The modulus function can be found under math. You press math, then you go to number, you go to absolute value here. Okay, so from here, what we'll get is this guy, sine x minus cosine. So sine x minus cosine x here. Okay, graph it. Okay, so look at the graph now. Usually I'll suggest is, because this is too confusing, right? So what you do is you can put one as dotted lines. Usually I'll just put the non-modulus as dotted line, so that I know what I'm referring to. Then after which you press OK, refer to the graph, then zoom to the place you're looking at. Look at the boundary condition here. The boundary condition is 1 to n, where n, okay, where n is anything between pi over 4 and pi over 2. Okay, so we're going to look at in our GC which part of it. So when we look at I'm going to go window, then I'm going to put this minus 0.1. Then we need pi over 4. X max is pi over 4, right? So this guy here, I'm going to put like pi over 2. Pi over 2 here. The maximum of n is pi over 2. Okay, so I'm going to restrict the domain for x, right? So I'm going to use pi over 2. Maybe I'm just going to add like say 0.2 here. Then I'll get this graph here. Okay, so obviously the x mean x, I'm going to put this as -1 and put this as 1 over here. Okay, graph it. So in this case, maybe I'll just put, I go to adjust a bit more. So my y max, probably I'll put 2 and -1. Okay, so it looks nicer. So this is the graph I'm looking at. Now the area that under the graph that I'm looking at is from here, 0 to pi over 4, somewhere around here. Okay, so let's just try and understand this graph here. So this is the crucial part. When we do this, right, understand that when I'm drawing the graph of the modulus sine x minus cosine x, there are two equations at play. Okay, so this guy here, there are two equations at play. One would be the positive one, and the other one, because when you open up modulus is plus minus, right? So there will be a plus minus. Okay, so from the graph we need to decide which is the plus and which is the minus. So obviously just now what we did here, this graph, that the dotted one is actually the, we plot it as the positive one, right? So anything which follows the dotted line is actually the positive equation. So in other words, this guy here is y equals to sine x minus cosine x, whereas for this guy will be the one that is being flipped up. So this will be the negative side. Okay, so this guy will be y equals to minus sine x minus cosine x over here. Okay, now this is important because we are looking at the integral from 0 to n. When here is 0, we are looking at this 0 here, and we know that n here, okay, is actually over here because it says that n is between 45 degrees to 90 degrees. So that's this is, so you need to break, you need to find the point here, the when this is 0. So I think not too bad. I'm just going to find this boundary first. So when y equals to 0, okay, so we know that sine x minus cosine x is equal to 0. So sine x equals to cosine x, and we know that tangent x is equals to 1 divided both sides by what do you call it, by cosine. We get tangent on one end, right? So this case here, what we'll get is then tangent x is equals to 1. So we know x will just be pi over 4, 45 degrees, right? 45 degrees where this is pi over 4. There you go, pi over 4. Okay, so now what we're going to do is essentially try to find the integral. Okay, so this case here, if you want from 0 to pi over, sorry, n, right? N is, okay, so we know there are two portions here. All right, so portion number 1 is that we take from 0 to pi over 4. We take, because from 0 to pi over 4, we are taking the negative graph. We're taking the negative graph. So this case here, we'll get is negative sine x cosine x. dx. Okay, then from pi over 4 to n, we are taking the positive graph. So this case here, we'll get pi over 4 to n, and we'll get sine x minus cosine x. There you go. This is the answer. So we can just start integrating the entire. So this guy, I'm gonna just distribute the negative in. So get negative sine x plus cosine x, right? dx plus pi over 4 and sine x minus cosine x dx. Okay, so then integrating negative sign will be negative this integrating sign with negative cosine. So this will be cosine x, then this will be plus sine x. Not an issue. Pi over 4, 0. Plus this over here will be negative sine x, negative cosine x. Okay, then it will be n over pi over 4. There you go. There you go. So we just substitute everything in. Cosine pi over 4 is 1 over root 2, I believe. Then sine over pi over 4, same thing, 1 over root 2. Minus of cosine 0 will be 1. Then this is sine 0 will be 0. Okay, so substitute everything in. This over here, what we get is. So this case here, what we're going to do is this is 1 over root 2. This is also 1 over root 2. This is 1 over root 2. This is also 1 over root 2. Then there you go. We have everything there. So I'm going to simplify. This is 1 over root 2 plus 1 over root 2 minus. This is cosine 0 is 1. Then plus. Then we just put negative sine n minus cosine n minus 1 over root 2 minus 1 over root 2. Okay. Simplify everything. So this is the answer. Now, take note, you remember that we could actually use a calculator and check for the answer, right? So usually this is what I tell my students. We key in both of the equation here. So because n has to be pi over 4 to pi over 2. So what I did here was, you can just key this in terms of n, put the modulus, remember that. Then we're going to put like 0.8, okay, or 0.9. Okay, this satisfy the value. Then you put storage. I'm going to keep this to n here. So now your n stored this value. You go up, you press enter, you key in, make sure to check our answer. This is the answer that we get. So the values, as long as they are slightly the same, then yeah, because sometimes there's some rounding error for the calculator. Okay, so that's how we do this question here. So if you have any questions at all, please do let us know. Now, see you in the next question.